You're walking around the catacombs deep underground. Suddenly, you hear something move in the dark. It gets closer, and as it closes in, it gets louder. You turn around to see a statue that wasn't there before. You try to walk away, but the second you turn your head, it gets closer again. You do your best to get away, but it's faster. No matter how hard you try, it catches up. And then... Enemies like these are called Weeping Angels, and they originally appeared in a 2007 episode of Doctor Who. But over the years, many games utilized their mechanics, like the Peanut from SCP Containment Breach, the Coilhead from Lethal Company, or the Endos from the worst FNAF game. And in this tutorial, I will teach you how to make an enemy just like those in Unity. But first, please consider subscribing and liking the video. I'm a really small channel, so every bit of engagement counts. Also, the game I used at the start as an example is one of my projects that you can play for free at the link in the description. Anyways, now that the self-promo is out of the way, let's get into the tutorial. I've set a basic scene up with a floor, some walls, and a basic first-person controller just so we have an environment we can test our enemy in. Let's start by adding a NUV mesh surface to our ground and baking it. This will be the surface our enemies will move around on. Next, let's set the enemy up. Create an empty game object and add the NUV mesh agent component to it. Then, under the empty game object, add a cube and scale it to be around the size of the enemy. Remove its collider and add a material to it that hides it. This will act as our bounding box that we will be checking visibility on. Let's make a script. I'll call it Weeping Angel AI, but you can call it whatever you want. Let's start by including UnityEngine.ai. This will allow us to use Unity's NUV mesh system. Next, let's make some references. First to the renderer of our bounding area, next to the layer mask of all the masks we want our wall checking to ignore, and lastly to the animator of our model, which you can skip if you don't have one. Also make two hidden ones that reference our agent and the player. In our start method, let's set our NUV mesh agent reference and our player transform reference. Next, let's make a new method that will return a bool. We will use it to check if we are in view or not. In our update method, let's check if we can move, and if we can, let's set our agent's destination to be the player's position. Otherwise, let's set it to be our current position. Back in Unity, let's add a simple mesh to our enemy so we can see where it is. Then let's set our components up. On the NUV mesh agent, it's important to set the acceleration and the angular speed really high, otherwise it will take our AI a lot of time to speed up. If we run the game, we can see that the enemy will get closer when we don't look at it. There is one major issue though. The isVisible tag only checks if the model is in the camera's view frustum, which means that it will still say true when the object is behind the wall. Luckily, we can fix this pretty easily. In our CanMove method, when the bounding array is visible, let's add an array cast that shoots in the direction of our player and outputs its hit data into a variable called hit. Then let's check if the transform of our hit is the same as the player's transform. If it is, then let's return false, since that means there is nothing between the player and the enemy. Otherwise, let's return true, since then there is a wall that blocks the player's vision. Now the enemy will move and the player's vision is obstructed by a wall. Let's set our visuals up next. In the update method, set the animator's speed based on the state. We will be using a single looping animation for the movement, and setting the speed to 0 will make it look like the enemy froze mid-motion. Next, let's replace the temporary visual with our actual model, and let's drag its animator into the script. If we test the game now, we will see that the enemy's pose changes slightly when it gets closer, but otherwise it's completely still. To finish things off, we need a way for the enemy to kill the player. Let's make a new script which will handle the death event. Include UnityEngine.events, then make a public event for the death. Back in the AI script, let's make a reference to the death event, and then let's set it in the start method. Next, let's add a float that will control the radius of the enemy's kill zone. Optionally, you can add a gizmo to visualize the size of the zone. Back in the editor, add the death event script to the player. I will use it to enable a simple death screen, but you can hook it up to basically anything. In the AI script, when our AI is moving, let's check if the distance is below our radius, and if it is, let's invoke the death event. And we're done. Our enemy moves closer when we don't look at it, and if it catches up, our death event gets called. And that's about it. Thanks for watching, I hope this tutorial helped you out.